So we are talking about petroleum. Petroleum, we have different fractions, components. According to this tower, if you observe that from the topmost vent, the gas is going out, that is C1 to C4. C1 to C4 again we are separating. C1 to C4 again we are separating. Mainly C1 is there into natural gas. And natural gas also divided into two categories, CNG and LNG. And there is a semi-synthetic one called petroleum, LPG, liquefied petroleum gas. These fractions we are getting from this topmost vent, C1 to C4. Just look at here, C1 to C4. This again we are separating to get natural gas in the form of CNG, LNG and LPG. CNG and LNG and LPG also we are getting from this fraction. Then you have C5 to C9 petrol, C9 to C10 naphtha, C10 to C16 kerosene, 14 to 20 diesel, and then the larger one lubricating oil and heavy oils. Now this heavy oil can be fuel oil or heavy oil that can be further undergoing some processing. It is called pyrolysis or cracking to make some synthetic petrol. So now in the current context, around 25% of our consumption is coming from synthetic petrol. So it is also not small. 25% of our total consumption is coming from synthetic petrol. What is synthetic petrol? The same fuel oil that we obtain from the petroleum fractionating column is further undergoing some processing, pyrolysis or cracking to prepare some synthetic petrol. Okay, so this is the thing. Now, this is the outcome. Name of the fraction, uncondensed gas. Below 30 degrees centigrade, 30-40 temperature is almost room temperature. Gas will not be liquefied, neither condensed. It is collected directly and then we are processing further to get CNG, LNG, LPG. Then we have petroleum ether. It is used as solvent. Organic solvent is a very common thing into chemical industries. Organic solvent, for any type of organic solvent, we are using this petroleum ether, which is quite useful. Then we have petrol or motor spirit. Again, this petrol or motor spirit we can call MO gasoline and AV gasoline, motor vehicle gasoline and aviation gasoline. Motor vehicle gasoline is used into vehicle and aviation gasoline is used into aeroplanes. Now, certain fraction of kerosene, white kerosene, is mixed with petrol to get the aviation fuel. Okay, so kerosene is not some way inferior. Kerosene is as good as petrol. It's not at all inferior. So because of government subsidy, kerosene was cheaper at the village area. Okay, it was because of government subsidy, diesel kerosene was cheaper compared to petrol, because it was assumed that petrol is used by luxurious one, it is used by rich people, and diesel is for all common people, because truck is running by diesel and all the food commodities, essential commodities like food, grains are transported by these trucks, and that's why the diesel supposed to be cheaper, otherwise the essential commodity will be very costly. Okay, so that is the reason, because of subsidy only. It is called cross subsidy. What is cross subsidy? Do you understand? Hey, listen everyone, don't talk. Cross subsidy. Achha, suppose up to 100 unit electricity if you consume, the rate is lower. If you are using more than 100, up to 500, you have got another slab. More than 500, you have got another slab. Different rate slot is there. But same electricity is generated from same mechanism. How possible that you are getting different rate? It is called cross subsidy. Those who are using below 100 means they are usually poor people or very common people. Okay, and those who are above that, those who can afford to consume 200, 300 unit or 400 unit, they are comparatively rich people. So they will bear more cost, and those who are poor will bear less cost. That is called government cross subsidy. Okay. So here also petrol, diesel, kerosene, the same thing was followed from long back. What is that? Petrol price will be more, diesel and kerosene price will be less. It was specified by government. Why? Because who is using that? Who is using petrol? Who is using kerosene? And who is using diesel? Just you have to keep this thing in mind. Petrol is used by rich people. They are running the car. Those who can afford car, they can afford a little bit of more price. And those who are poor people, they cannot afford that much. So for them, kerosene should be cheaper because kerosene is used into lantern, gas, kerosene stove. So those who are people, poor people, that's why that's cross subsidy was given. And that's why price of petrol is always higher, and we have a natural feeling that kerosene is inferior compared to petrol. That's why it's cheaper. This is a wrong concept. Actually, they are all coming from the same petroleum fractionating column, so price should not be different. They should be all equal. But because of cross subsidy, petrol is costly, diesel is cheaper, kerosene is cheaper, like that. তুমি মেসেজ করেছিলে করোনি, সেটাকে আমি লেটই ধরবো. Late means you will get all 7 gross. Whatever you do, not more than 7. Late means 7. Link কিসে লিঙ্ক আদর কানে হার্ড কপি থাকবে আমার কাছে. Okay, see, then you have naphtha. What is the purpose of naphtha? Naphtha we are cracking to prepare raw material for, or raw material is monomer for the polymer beads, for making polymer beads. That is the purpose. So that's why naphtha cracker unit, yesterday I mentioned, naphtha cracker unit at Huldia Petrochemical. This naphtha, size C9 to C10. This is cracked further to produce small fragments, ethylene, mainly ethylene. That is our target. Ethylene, propene is target, because from that we can prepare the polymer. Monomer is ethylene, so make it polyethylene beads. Okay, kerosene oil, that is, you already told you, it is mixed with petrol and it is used into our aeroplane vehicle, not vehicle. So motor gasoline, it is called MO gasoline, and aeroplane gasoline is called AV gasoline. They are a bit different, composition different, nothing else. This only this same. And yesterday told na, the longer the carbon chain, more will be the calorific value. So aeroplane calorific value is supposed to more calorific value required, because aeroplane means you have to give some lifting also, lifting power, not only propagating power. You have to have lifting power plus propagating power. So lot of energy is required, lot of thrust required, otherwise not possible. So vehicle can move with a lesser calorific value, but aeroplane cannot move. That's why the calorific value is supposed to be more, and so kerosene is added. Okay, truck. Why truck is not running by petrol? It is running by diesel. Why? With longer chain, it will give more calorific value, and that's why calorific value in the sense in terms of kg. Okay, kilocalorie per kg, that is the unit. It is a liquid, and if it is a gas, then kilocalorie per meter cube. That's why you always cannot compare these two things, because the unit is different. Now heavy oil, this undergoes cracking, and we are actually making gasoline out of that, means petrol. So MO gasoline, AV gasoline, understood? MO gasoline and AV gasoline, motor fuel gasoline and aviation gasoline. This is MO gasoline and AV gasoline. Composition is different. In AV gasoline, we are mixing kerosene. Acha, what is the color of kerosene? Blue. Acha, what is the color of petrol? Reddish type. Acha, why these colors are actually mixed? Because pure, all the hydrocarbons are colorless, odorless gas, colorless, odorless liquid, and all. Or not odorless, colorless. They are all supposed to be colorless. Odor is there, smell is there, but it is colorless. All of them are colorless. Which one? All hydrocarbon in general are colorless. So how we are getting colorful things? Petrol is colorful, diesel colorful, everything colorful. Not colorful? Okay, I have not used. Achha. So petrol using, so that's so you know very well. Kerosene you have seen, but a different color. Why it is added? Why added separately? Color is added. Why? Otherwise, people will buy kerosene at subsidized rate and mix with the petrol. So if it is of two different color and if you mix it, it will be dirty color. Nobody will buy it. Okay, that is the trick. That's why from government level only, that all the petroleum sector, Bharat Petroleum, IOCL, IPCL, whatever. So they are all adding this color because of that purpose. There is a government directive. That's why they are adding these colors. Petrol, diesel, everywhere the color is. Diesel is totally colorless. Okay. So there is some yellowish tint, na? Yellowish tint. Not purely colorless means water, not like water. Is it? Water মতো না, একটু কালার আছে, সামান্য একটু অন্যরকম দেখতে। মেশালে কিন্তু গন্ডগোল হয়ে যাবে, কালার চলে যাবে, বাজে কালার চলে যাবে, সে মেশাতে কিছু পারবে না, ক্যানট মিক্স এনিথিং। দ্যাট ইজ দ্য পারপাস, রিজন। আচ্ছা, গ্যাস ইজ অলসো অর্ডারলেস। আওয়ার কিচেন গ্যাস ইজ অর্ডারলেস, but actually when there is a leakage, you get the smell. Some smell is added, separately added. Originally it is colorless and odorless. See, hexane is there is a smell. গন্ধ কিছু নেই তো, কিছু ওটা বিউটেনের গন্ধ নয়, দ্যাট ইজ এ সাম সর্ট অফ দ্যাট স্মেলিং কম্পাউন্ড অ্যাডেড। হ্যাঁ হ্যাঁ, if there is a leakage we can make out easily. That's why there is a gas sensor, that system is also there. If there is a totally colorless, odorless, everything, so nobody can sense. Sensor also will not work. That's why some smell is added, so the leakage can be detected easily. Okay, gas sensor is there; it can detect that there is a leakage. Nowadays the chimney is there along with the gas sensor, so the gas sensor can sense there is a gas leakage, so automatically it will run the chimney without any of your interruption. It will automatically run the chimney. That is gas sensor system. Okay, and running chimney means the gas will be going out, so it will be ejected out. Now one by one, let's understand gasoline. See the property of gasoline. It is pentane to octane, pentene to octane also to some extent. It is obtained between 40 to 120, as I told yesterday. Calorific value 11250. Let's understand the calorific now. Kilocalorie per kg 11,11250. It is highly volatile and inflammable. And one problem of gasoline is there. It is highly volatile. That is a problem for some time, some system. Okay. So it is not always used in all type of engines. It is used only in internal engine where there is a proper sealing arrangement. There should not be leakage, no? That's why there is a proper sealing arrangement. So in the IC engine or internal combustion engine, petrol is used. Inflammable means it will catch fire by itself so easily. Suppose there is a little bit of collision between two trucks and one truck is carrying gasoline, so there will be automatically it will catch fire by the jar. You don't have to give any type of matches. You don't have to light the match. So automatically it will catch fire because of friction. When collided, there is a friction. Na? Because of friction, there is a jerking also, jerking and friction, and by that, automatically it will ignite. That is so dangerous. Petroleum. That's why petrol is very dangerous. Not the crude petroleum. Petrol is more dangerous. Why? Gas is available. Whenever in the tank there is some amount of gas trapped there above the petrol, the gas is there. So that's why we call it gasoline. That's true. Yesterday I told you, no, it's not a joke. It's really, the gas is always contained along with the liquid. That's why it is called gasoline. And so this gasoline is we can use in the internal combustion engine. Now coming to diesel, it is a mixture of higher hydrocarbons Cetane to C18, as I told you yesterday. It is octadecane to what is the Cetane is called decane to octadecane. Achha. Now Temperature range is 250 to 320 centigrade, calorific value 11000. Acha, now diesel is actually less, na? Yesterday told you, yes, I remember that. So it is 11250, it is 11000. It is because of this one problem. This mechanism of the burning is different. For petrol, what you are using, that ignition is done by some spark plug. And for diesel engine, there are two this nozzle, one diesel jet, and in the other one is compressed air jet. These two jets are knocking, and there is no spark plug. Automatically ignition is there. The mechanism is different. The engine is different. Petrol engine is running by spark plug mechanism, and diesel engine running by this mechanism. It is called internal nozzle system. So it is compressed air. One is compressed air, other one is the compressed fuel vapor. Those two are jet are knocking together and automatically ignites. Okay, this type of open the spray for petrol can be very dangerous. So in the diesel vehicle we cannot use petrol, and in petrol vehicle we cannot use diesel. Okay, because why? The engine is different, the mechanism is different, entirely different. We for petroleum IC engine system, we want very easy ignitable fuel, very easily ignitable fuel that we need for IC engine. For diesel engine, we don't need that. We need comparatively less combustion property. Why? Because these two jets are just knocking and it is happening into some chamber, but that is not that much of seal. Not that much of seal. Spark will be automatically generated, but the spark plug is not there. Those mechanism different. So though there is calorific value little bit less, not much less. Petrol, diesel, see the difference is very little. So this diesel, is not used because the engine is different. Kerosene engine কোথায় ইউজ হয়? কেরোসিনে বাস চলে কোথায়? এখন সব গ্যাসেই চলছে। দুটো অল্টারনেটিভ আছে, একটা হচ্ছে ডিজেল আর একটা হচ্ছে গ্যাস, সিএনজি গ্যাস, সিএনজিতে চলে। যে এসবিএসটিসি বাস কিছু সিএনজি চলে, সিএনজি আর সব না, কিছু সিএনজি আর কিছু আছে এমনি নর্মাল ডিজেল। সিএনজিগুলো তলায় ট্যাঙ্ক থাকে, দেখতে পাবে ঝুলে আছে ট্যাঙ্ক।
আপনি বললেন না ওই পেট্রোল ইঞ্জিনে ডিজেল দিলে ডেঞ্জারাস, কিছু হয় না স্যার?
ইঞ্জিনটা খারাপ হয়ে যাবে আর কিছু।
হ্যাঁ, ইঞ্জিনটা খারাপ হয়, এমনি কোনো কিছু হবে না,
ইঞ্জিনটা যাবে শেষ হয়ে। আচ্ছা, নেক্সট কেরোসিন অয়েল 182, it does not vaporize easily. দেখো, hey, this does not vaporize easily, so cannot use into IC engine. It should vaporize easily. কেন? Fuel vapor and air mixed into carburetor. So if vapor is not generated, if it is a liquid here, so then how can you put into the carburetor? In the carburetor, gas mixing goes on, not liquid mixing. So one mechanism will not work into another system. Mechanism is different, engine is different. How you cannot run? Should not run. Your efficiency will be low. If you run one system into another, efficiency will be very poor. So it is very clearly mentioned here. See, it does not vaporize easily because high boiling point. You are going for a higher and higher boiling point. Sometimes that is advantageous. Fire hazard will be less. If it is a low boiling, so it can catch fire easily. If it is high boiling, the risk is less. Next, coming to very important topic, cracking. Okay? Hints. This may come in the exam. Okay? So, get to understand this. You must understand this. Cracking. What is cracking? Cracking is breaking the large molecule into small one. Say decane is broken into two fragments. One is pentane and is pentene. Why not pentane? In that case, you cannot get the balanced equation, you see. You will understand hydrogen will be less. One decane, if you break into two pentane, not possible because two hydrogen will be less. Count the number of hydrogen, you will understand. It's not possible. So one pentane and one pentene. That is the cracking goes on. What is cracking? By heating, you break the molecule. Now this breaking of the molecule into two fragments, that also has different ways. Either you can go by thermal method or you can go by catalytic method. Catalyst most of the time is found to be advantageous. If you use catalyst, you apply less heat. Less heat means less fuel. Whenever you are heating, means you are supplying some fuel, burning some fuel. Whatever fuel may be. That may be electricity. Electricity is also not free. This is also coming out of burning some fuel. So some fuel either earlier or now you are burning. Now and then you are burning always. It's okay. So when you are supplying heat or heating something, means you are there is a cost involved. That is fuel cost, right? So if the processing can be done at a lower temperature, is always better. So in that case, your fuel cost will be less, economically more viable. So in that case, catalyst is used, and that catalytic cracking is always advantageous. There are two types of cracking. One is called thermal cracking, and there is called catalytic cracking. Now thermal cracking, that is easy because you don't need any catalyst, anything. Achha, don't need to have any type of special setup. Just heat, it will crack. Achha, how much heat? Not very much, because if you apply very high temperature, it will be very risky. Fuel, na? It will automatically catch fire. So that's why there should be control heating. 600. Normally for distillation, how much temperature was there? I already told you. 450, 500, 550. Cannot cross 550. Okay, within that range. 450 to 550, something like that. Slightly higher, cracking will start. Around 600, cracking will start. So you are taking more risk. More temperature, the more the risk. Fuel, na? So cracking is done at around temperature 500 to 600. But thermal cracking, temperature will be slightly higher, and catalytic cracking, temperature will be at least 50-60 degree less. So risk is less, fuel cost is less. That's why catalyst. Now this catalyst can be two types. One is called fixed bed catalysis. Another is called moving bed catalysis. Fixed bed catalysis. Bed means? Bed means normally we jani bichana. But in this case, bed means is some sort of suspended system. Suspension, solid surface, something like that. So that bed is made of some catalytic particle, and through that the gas vapor of the fuel, you are allowing to pass through. So it will break into two fragments like this. So that is cracking. But you are using catalytic bed, so in that case it will be called catalytic cracking. Catalytic cracking. So it is fixed bed catalysis. The bed is fixed and the fuel vapor is going through that. So it is called fixed bed. And there is called moving bed. Moving bed means there the particles, catalyst particles are in the form of a fluidized one. Fluidized means small particles are flowing. So then it's called fluidized. Fluidization is a term, chemical engineering term. Fluidization. What is that? This solid material is normal, it is not a fluid. Fluid means what? Anything that flows is called fluid. Liquid and gas, they are fluid. But solid is not a fluid. But if you can make it flow, then what do you call it? Fluidization. Simple idea. Gas and liquid is always flowing, so they are fluid. Solid is not flowing. If you can make solid to flow, then you call it fluidization. How can you do that? Blow. With a blower, blow. With a blower, you take the catalytic particles and allow it to flow into the container. Udiye dao. Dust particles are flown. So it is fluidization. Now in this case, I am talking about catalytic particles. These catalytic particles, you are flowing inside some chamber. And from opposite direction, your fuel vapor is coming. There is a counter current interaction and temperature also. By this counter current interaction with the catalyst as well as high temperature, cracking will take place. That is called moving bed. Is the concept clear? One case, the catalytic bed is fixed and the gas is passing through, the vapor is passing through and cracking going on. That is called fixed bed catalysis. Another one, fluidization of the bed. The small catalytic particles are flowing and opposite direction, the vapor comes in. There is a counter current interaction and cracking taking place. That is cracking.
Why does he use the different type of process?
No, actually, there is a lot of research already in the industry. Cost minimization, maximum profit. Otherwise, you cannot run the company. Go and go on for research and research and research. So whatever data available, you cannot be happy with that. Go for a betterment. Those who are in the manufacturing industry, they are also always doing the research. How can you do betterment? So these are this matter of research. They are just doing different types and just finding out which one is best for which company. Small factory, big factory, obviously same process will not be helpful. Small factory, one technique. Medium factory, some other technique. Big factory, there is some other technique. Okay, I am giving some rough idea. Suppose you are taking 10 gram of some monomer and doing the polymerization. It is your test. You are doing a test. You are taking 100 gram, still it is laboratory test. You are showing some student, okay, 100 gram polymer we are making. That is a test. It's a trial. Now, a few kgs you are making. That is called pilot scale. Pilot scale. Now, in a manufacturing scale, you are making it out of ton. So, when you are making 2 gram or 10 gram, and when you are making 2 ton, there is a hell and heaven difference. Why? Because in this case, you can mix it by your hand, by stirrer, and when you are taking 2 tons, how do you mix it? By some motor. Okay? It may not be quite useful, it may not be sufficient. Then what will happen? Outside the peripheral area is not properly stirred, central area is stirred. So in the central area, you are getting some quality of polymer, and the peripheral area, you are getting different quality. So what ultimately, what will be your achievement? How can you sell this thing in the market? There is a big difference about a small scale and a large scale. That's why research is always there. Your paperwork, your data, what you are supplying is not good enough for the company. They are dealing with tons, so they are always doing research. Thermal cracking, catalytic cracking, as I have already discussed, just have a look. I already told you. Temperature, they are telling high temperature, 75 degrees is very high temperature for this system. Why? Because fuel, 750 means very high. Dangerous, dangerous. And pressure, 70 atmosphere. Very difficult to make 70 atmosphere pressure. Okay. So in the laboratory, cannot do it. 70 atmosphere pressure we cannot create in the laboratory. It is possible only in the manufacturing industry, where they will invest a lot. Matter of investment is a lot. Then catalytic cracking, temperature is 500. See, 750 and 500, lot of difference. Onekta kom. And moderately low pressure. Mane koto? 1 to 2 atmosphere. কোথায় ছিল 70 atmosphere, এটা হচ্ছে 1 to 2 atmosphere. Almost there is a lot of downgradation of regarding pressure. Temperature 250 less and pressure is quite low. So that is quite advantageous, because your cost of everything will be reduced. Pressure is not free. For creating pressure also you have to make some arrangement, which is a matter of so many lakhs or maybe crores. Isn't it? So if you can make it a low pressure system, ordinary pressure, or maybe 1 to 2 atmosphere, 1 to 2 atmosphere is nothing for industry. So it can be done. Zeolite, aluminum silicate, that is the bed, catalytic cracking bed. Aluminum silicate bed. Okay. What is the purpose of aluminum silicate? Aluminium is found to be very good catalyst for this type of material.
Because the
no, aluminum particles. Aluminum particles. Particles, solid. It's not boiling going on. Aluminium is not boiling here. Aluminium is a catalyst. Aluminium is the catalyst here. Aluminum silicate is a bed. Aluminum silicate compound bed, and on that cracking is going on. Okay, catalysis is chosen to give high percentage of hydrocarbon between 5 and 10 carbon atom. So equal size hydrocarbon will not get 5, 5, 4, 6. So uneven breaking. That is quite obvious. Never expect that if you break a decane, it will give you pentane and pentene. Pentane, pentene, hexane, butene, hexene, butane, lot of combinations. But whatever may be, that does not matter, because all these mixes are coming in the category of petrol. No, aluminium is found to be effective catalyst here, that's all. Just like Oswald process, Haber's process, there is a specific catalyst. Why? It is tested, that is found good. Tested, that is good. দেখা গেছে metal you have to use, but which metal will be the best, that you have to give the trial. And trial is given, optimization of temperature, optimization of pressure, catalyst, promoter, everything is checked and decided. And that is your ISO standard. In the Google, if you give search ISO standard for this, ISO standard for that, they will give you the procedure, everything. After that, you have to do your further research. What is the best for your industry? So this is zeolite catalyst bed. Say how the bed is working, that is given here. That hydrocarbon, no? Combination of hydrogen and carbon, hydrocarbon. Some hydrogen is captured by the zeolite catalyst. And that way, it promotes the breaking. Because, stop talking. Alkanes are normally very, very inert. That you know? Alkanes are normally very inert. That you have heard in the class 9 standard. Isn't it? Alkanes are very, very inert. So normally they will not react automatically. Just heat and it will react. It is not so simple. Because they are inert. Why? Because alkane is quite completely stable molecule. It is saturated. Huh? Saturated stable molecule. There is no double bond anything. You have to create some instability by this catalyst. You are purposefully creating some instability to the catalyst. Okay? And it is happening. So these molecules are reorganized, reorganized and then broken. Gasoline, which one is among all the petroleum products, which one is maximum demanding material? That is petrol. Among petroleum products, which one is the most effective material? Petrol. Okay? Maximum demand is there for petrol. Petrol, diesel, obviously. Now, petrol is one of them. So, but the fraction is how much petrol you are getting from petroleum product. Only 20 to 30% is petrol you are getting. If you take 1 liter of crude oil, you are getting 200 ml of petrol. More or less. Achha. Then 800 ml is for other things. Only 20%, 25% you are getting petrol. But that is most essential. Petrol is the most essential. Because maximum vehicles are running by petrol. So then not only that, petrol is mixed for aeroplanes also. Aeroplane vehicle also. Now, this how do you meet that demand? Demand is very high, supply is less. So that's why the purpose of cracking is there. By cracking, at least 25% of our demand is met by this by heavy oil, by fuel oil, by cracking of kerosene oil. Different way we are preparing this petrol. From petroleum we are getting petrol directly. One more thing, from petroleum, what petrol we are getting directly, the gasoline directly we are getting, that is called straight run gasoline. Okay? You may write down, you will forget. Write down. Straight run gasoline. Without any further modification, when the gasoline is directly taken from the fractionating column and used into vehicle, it is called straight run gasoline. If the petrol is collected from the fractionating column and directly used up in the vehicle, it is called straight run gasoline. Straight run. No further processing is done, so it is straight run. But straight run gasoline, if it is used from directly from the petroleum fractionating column without further modification, that is called straight run gasoline. Sometimes we are using straight run gasoline, but straight run gasoline contains some amount of sulfur, still some amount of sulfur present. For removal of that, further refining is required. That is called petroleum refinery. petroleum fractionating column is the separation of different fragments from petroleum. Straight run gasoline. If it is directly used after the fractionation, without further modification, if it is used, it is called straight run gasoline. Usually, it is further refined. And refine means what? What is refining? Refining of petrol. What is the meaning of the term? Refining of petrol. Removal of more and more impurities. Removal of more impurities, particularly sulfur. And if it is done or modified, then it is called refined petrol. What modification? Octane number is enhanced. Octane number. Have you heard about octane number? Acha. Now in the petrol pump, there are two types of petrol available: direct petrol or others power. What is power? How can you give power? How can you give power to the petrol? Petrol is usually powerful. How are we giving power to the petrol? Actually, the octane number of that petrol is higher. Octane number of that petrol is higher. Artificially, you are making octane number higher. How? We can do it so many ways. Number one, you can add some lead additives. Earlier, people used to use lead additive to reduce the knocking problem. Okay, I'll discuss what is knocking problem. Then only you will understand. So, for the time being, let's go ahead. So, I'll discuss now. Next, let me finish this. Then, moving bed or fluid bed catalyst. I told you, fixed bed and moving bed. So, this is moving bed. Moving bed means I just simplified you, but actual situation is very complicated. Simple way I told you, but the actual situation is not that simple. The situation is like this. So, the gas is coming in one direction and the particles of this catalyst is coming from the other direction. There is a counter current interaction. And by that counter current interaction, there is a cracking going on. And after cracking, what you get? Catalytic cracking, what you get? The petrol alternative. It is also petrol. I am calling it petrol alternative because it is not directly coming from fractionating column. You are making it, so it is synthetic one. So it is synthetic petrol. So the synthetic petrol is also giving some of our demand is making, and there is a quality control checking always. Now coming to the point, what is cracking? Okay, this I have explained. Now coming to the cracking. What is cracking? I told you. Knocking. Knocking. What is knocking? Knocking is a peculiar noise coming from the IC engine. Okay, there is a peculiar knocking sound coming from the engine. Duck, 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 duck sound. So whenever that happens, that means your fuel is not at par. The quality of your fuel is not at par. Otherwise, this noise should not come. And why the noise happens? You have to understand the mechanism of the petrol burning. There are 4 steps. First is intake, then compression, then power stroke, and finally exhaust stroke. Okay, intake means it is coming in, taking in. After that, compression, pressurization, compressed fuel, and then spark plug will ignite. That is called power stroke. And then it is creating lot of pressure. After burning, lot of pressure generated. Why pressure generated? 100 ml fuel will produce 1 liter or more than 1 liter of burned gas. 100 ml of fuel, if you burn, you will produce more than 1 liter of the gas. Now imagine if it is 1 liter, then you get 10 liter, 12 liter, 13 liter. Okay, depending on composition, it can be 12, 13 liter also. So 12, 13 liter of gas produced in this much of small space. So how much pressure will be generated? By that pressure, one valve will open up and the gas mixture will go out. That is called exhaust stroke. So intake, it is called intake stroke, and then compression, and then power stroke, and then exhaust stroke. Now, what is happening out of these 4 strokes? Sometimes what happens, in the compression stroke itself, before the ignition, automatically it catches fire. Then the fire is inside the piston, not inside the rotor. Because the engine has two parts, the piston part and the rotor part. The combustion should happen inside the rotor part. But if it is happening inside during the compression itself, that means inside the piston part only the combustion started. It will give peculiar noise. And not only noise, it will give low efficiency and the damaging the engine. Engine will get damaged also because it is not manufactured that way that combustion will be in the piston. It is manufactured that the combustion will be in the rotor part. So in a wrong position, wrong timing is there. Combustion is there in the wrong timing and wrong position. So that will reduce the efficiency of the engine and damages the engine. That is called knocking. Could you understand knocking? Knock knock শব্দ বুঝো knock knock মানে কি ধাক্কা তো এখানে একটা ধাক্কা পাচ্ছে তুমি ইঞ্জিন ইজ গেটিং সাম সর্ট অফ সাউন্ড ঢাক 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 সাউন্ড সো সামওয়ান ইজ নকিং ফ্রম ইনসাইড লুকিং অ্যাজ ইফ ইউ ফিল লাইক দ্যাট মনে হচ্ছে ভেতর থেকে কেউ ধাক্কা মারছে সো হোয়াই ডাজ ইট হ্যাপেন বিকজ অফ প্রিম্যাচিওর ইগনিশন টাইমের আগে চলে যাওয়া before your timing the combustion started, that is not desirable. Okay, and that is a problem. It is called knocking, and this knocking problem is there for petrol, not for diesel or kerosene or anything. Why it is? Because it catches fire so easily, that's why it happens. As catches fire so easily, handling it will be a bit more difficult. Petrol handling will be more difficult compared to others. That's why it is not used in everywhere. It is used into only the IC engine. Got it? Now, knocking is there. So how do you reduce knocking? Could you understand or not? Clearly tell me. Knocking? No, na? বুঝতে পারো না আচ্ছা নকিং হচ্ছে একটা নয়েজ নকিং ইজ এ নয়েজ দ্যাট ইজ কামিং ফ্রম ইঞ্জিন অ্যান্ড দ্যাট হ্যাপেন্স বিকজ রং টাইমিং দ্য কম্বাসন হ্যাপেন ইন্টু রং টাইমিং টাইমিং মানে কি আউট অফ 4 strokes it should happen in the third stroke third step it should happen in the third step but the combustion it happens in the আপনার চেকটা রেডি করা আছে আপনি বাড়ি থেকে নিয়ে নিতে পারেন বাড়িতে রাখা আছে আচ্ছা আমি এখন ক্লাসে আছি তো কথা বলবো কি করে আমার ক্লাসটা রেকর্ডিং হচ্ছে So catalytic cracking and knocking. I was discussing knocking. Knocking is a noise. Knocking is a sound. Okay. Knocking is a noise. Knocking is a sound. It is happening because of premature combustion. Before the timing, before the right place, not in the wrong place, wrong timing, the combustion is happening. It's not difficult to understand. Wrong timing, wrong place, the combustion is happening. That is knocking. Now, how to reduce that knocking? How to reduce that knocking? How to solve that problem? Okay? There are different ways we can solve the problem. Number one, we can use some lead additive, TML, tetraethyl lead or tetramethyl lead. Acha, I have not told you yet that why does it happen. I think that will clarify your all problems. Why does it happen? This knocking. Okay, I told you what is knocking and when it is happening, but why it is happening that I have not clarified yet. That is because a lot of radical generated. The straight chain hydrocarbons are very easily fragmented, producing small radicals. If cracking happening, just imagine, if cracking happening into this catalytic cracking system, thermal cracking system, why not cracking happening inside your engine also? There also you are heating, there also you are pressurizing. Pressure, temperature both are using in the engine. So why not cracking? And that cracking is giving knocking. Got it? No. আরে শুনছো না মন দিয়ে একটু ভালো করে শোনো আরেকবার মন দাও
স্যার এই
ক্র্যাকিং আর নকিং এক নয় ক্র্যাকিং মানে ভেঙে যাওয়া নকিং মানে সাউন্ড হওয়া এইটা হচ্ছে ভেঙে যাওয়াটা ক্র্যাকিং আর এটা নকিং দুটো কি করে এক হয় নকিং হচ্ছে সাউন্ডটা ক্র্যাকিং হচ্ছে ভেঙে যাওয়াটা মানে ক্র্যাকিং অফ মলিকুল Cracking ki se? Cracking of molecule. You are breaking the molecule, so cracking. Molecule you are breaking into small fragments. Cracking. And knocking is a noise. And why does the noise happen? Because the combustion is happening in a wrong time, wrong place. Combustion is happening in the wrong time, wrong place. Now why it is happening? Because cracking is happening. Why knocking is happening? Because cracking is happening.
Cracking কেন হবে?
Temperature, pressure we are giving, na?
অতটা টেম্পারেচার তো পাবে না স্যার, 700 কোথায় পাবে ইঞ্জিনে?
হাত দিয়ে দেখো, বুঝতে পারবে কতটা প্রচন্ড।
700 মানে বুঝতে পারছি।
আরে cracking may start, na? Not go very smooth, but some molecule can crack, na? Some molecule, it is not industry, it is a small scale. Some molecule may crack, and because of this molecule cracking, radical generated, CH3 dot, C2H5 dot generated. These things, listen, due to this small scale cracking, this I can say small scale cracking. Due to this small scale cracking, some radicals will be generated. Methyl, ethyl radical, propyl radical, these radicals are generated. Now these radicals are giving chain reaction. It is giving chain reaction, that's why automatically ignition starts. Radical, when combination, producing energy. First broken into radicals. Some radical recombine, producing lot of energy. Okay, that way it combustion gets started. Okay, I'm analyzing again. Molecules are fragment, size 7, 8, 9 carbon chain molecule. Now, when you are compressing, heat generated. Due to compression, heat generated. Then this up and down, piston up and down going on, heat generated. Now that type of heat and pressure also, compression means pressure also, so that heat and pressure can convert some of the molecule into small fragment, and that is giving radicals, methyl radical, ethyl radical, propyl radical. These radicals can give some chain mechanism, chain reaction, and as a result heat generated more and combustion started. Once the combustion started, that happens by itself without any spark plug.
আপনি বললেন যে কম্বাসন যখন হচ্ছে তখন ক্র্যাকিং ওখানে টেক প্লেস,
কম্বাসন শুরুর আগেই ক্র্যাকিং হয়ে যাচ্ছে।
কিন্তু কম্বাসন না হলে প্রেসার আর টেম্পারেচারটা পাবে কোথা থেকে?
প্রথমে তুমি যে কিক করছো তার থেকে, তখনই তো কম্প্রেশন স্টার্ট হয়ে গেছে, কিকটা করছো তো, বা আমরা চাবি দিয়ে ঘোরাচ্ছি তখনও তো একটা ইয়ে হচ্ছে, ওখানে তো প্রেস, চাবি দিয়ে যখন ঘোরাচ্ছে তখন একটা প্রেশার ক্রিয়েট হচ্ছে, ওখানে মোটর চালু হচ্ছে, ওখানে গিয়ে প্রেসারাইজ করছে, ইট ইজ প্রেসারাইজিং অ্যান্ড ক্রিয়েটিং হিট, অ্যান্ড দ্যাটস ওয়াই ইগনিশন স্টার্টস before spark plug working, the ignition gets started. Once the ignition gets started, okay, it is giving noise, peculiar noise. Now come to the point, how can we control this problem? To control this problem, there are three, four different ways. Number one, we can use some tetraethyl, tetramethyl lead. Tetraethyl lead or tetramethyl lead. These lead compounds can capture radicals. Radical generated, the trouble is radical. The radical, if you can capture, the problem can be minimized. So, tetraethyl or tetramethyl lead is absorbing those radicals. Tetraethyl or tetramethyl lead is absorbing those radicals. Okay, tetraethyl or tetramethyl lead is absorbing those radicals, and as a result, radical is reduced. So this chain reaction is stopped. Some of the radical, if you can capture by some way, this chain is broken. The chain reaction cannot continue, so it stops, and the problem is over. This is one problem. But by doing that, you are arranging another problem, lead pollution. Isn't it true? If you want to reduce this problem by adding lead, tetraethyl lead and tetramethyl lead, you are using lead compound. That will create another trouble, that is lead pollution problem. Okay, so let's go for another alternative. Second alternative is, instead of straight chain hydrocarbon, if you use branched chain, this problem is less. So use more branch chain. How do you get branch chain? Modify it. That is called reformation. reformation. So instead of using straight run gasoline, let it undergo reformation, and you will get more branch chain molecule, and the knocking problem will be less. Straight chain producing more radical, branch chain producing less radical. So go for more branching. That will solve all the problem. But you don't get ready-made branching. Branching you have to do yourself. That is called reformation. How do you do it? Again by catalyst. Almost similar condition. Cracking condition is something similar condition. Slight temperature pressure variation, and the catalytic bed will be something different. Aluminium sulfate, TiO2 bed. Aluminium sulfate, TiO2 bed. This type of catalytic system can convert straight chain hydrocarbon into branch chain, and the problem is less. Knocking problem will be controlled. So this catalytic cracking I have finished. So knocking, yeah, I was talking about. More branch chain. Nowadays lead compound is not used. Earlier people used to use lead compound, but nowadays in the petrol pump it is written no unleaded petrol. That means lead compound is not added. That's why called unleaded. Maybe you have seen somewhere written unleaded petrol. That means lead compound not added. Then what is added? Something have to add? Then that is branch chain. Power petrol to আমি নিয়মিত কিনি বিধাননগর পেট্রোল পাম্প থেকে নিয়মিত কিনি পাওয়ার পেট্রোল it is called XP95 depending on company একটু বেশি দেয় আর দামটাও সে একটু বেশি পড়ে ব্যাপারটা একই বেশি ব্যাপারটা একই ইকোনমিক্যালি সেম বাট ইঞ্জিনটা ভালো থাকবে বলে কিনি বাইক কার পেট্রোল গাড়িতে দেয় ডিজেলে তো ওগুলো দরকার নেই পেট্রোলের Achha, okay. So this is internal combustion engine. See, this is internal combustion engine. Achha, these are not 4 engines. One engine, 4 steps. Intake. This is intake. Then compression. Then ignition, and then exhaust. Those are 4 steps. First, fuel vapor is entering. Fuel vapor air mixture is there. After that, compression. Piston goes down. See, this is the piston. Piston is going down. So compression started. Then after that, spark plug ignition, followed by your exhaust. Oh, I am going opposite way. I think this is the combustion. It is fire is going. No, this is the fire. This is input. Then compression. Then power stroke, and then exhaust stroke. 4 step. No, this is the first step, second step, third step, 4 steps. এটা হচ্ছে entering the fuel vapor and the air. Here, this piston is going down, so compression. After that, ignition, spark plug is ignited. This is the fuel started, burning started. That red spot, that means ignition started. After that, there is a fire. You see, combustion is complete. There is fire. You can see the fire. From that I understood that this is actually last step. So after that the gas mixer going out. This is another way of understanding. এটাও দেখতে পারো intake valve.
But in case of diesel engine there is no spark.
No, there is a different mechanism. I'll explain the mechanism. This is different mechanism. This is only for IC engine.
So this is for
Petrol.
This is for 4 stroke.
4 stroke. 2 stroke nowadays obsolete, gone from the market. Can you give one example of 2 stroke vehicle?
Yamaha RX100.
2 stroke vehicle. I have used long back 2 stroke vehicle. Small Luna, kinetic Luna, 2 stroke vehicle. Not at all fuel efficient. It used to burn too much of fuel. Consumption was too much. Mileage was very low. 2 stroke, na? Mileage is very poor. After that 4 stroke came. When 4 stroke came, 2 stroke became obsolete. উঠে গেল বন্ধ মাইলেজ খুব খারাপ okay these 4 steps knocking I was discussing knocking also I told you first I have discussed everything now I am showing you just see knocking means পড়ে নাও একবার পড়ে নাও সব বলেছি rattling sound kat rattling sound okay produced in the internal combustion engine due to immature ignition আমি বলছিলাম প্রিম্যাচিওর ইগনিশন, এখানে বলছি ইম্যাচিওর ইগনিশন। ফাইন। The presence of some constituents in the gasoline used causes the rate of oxidation becomes so great that the last portion of the fuel air mixture gets ignited instantaneously, produce an explosive violence called knocking. Straight chain paraffin, you have to make branch chain. Then if you can straight chain, if you convert into branch chain, then this knocking problem will be less, and it is called reformation. So octane rating, octane number, okay, octane number. Octane number is what? I will try to explain. It is written everything, but still you just can read out. I will still explain. You have two standard. Hey, Munda. There are two standards. One is N-heptane, another is isooctane. This is one standard, this is another standard. This standard is very poor in terms of knocking problem. That means knocking is very high. So that's why octane number rating for this molecule will consider 0 because very poor. So octane number high is good. So octane number 0 means very poor. So okay, we are considering this octane number. না বুঝবো না, স্ট্যান্ডার্ড নিচ্ছি আবার বুঝবো কি? I'm taking a standard. This is actually the combustion characteristic of this one is very poor. So I'm taking a standard 0. You want to get minimum and maximum. So minimum is this, and maximum is very good one is this. So 100. This is very good one. This is a very poor one. Very poor one in terms of this knocking problem. So you are taking this 0, and this I am taking 100. Now, every fuel, if you mix up any fuel coming from any petrol pump, hey, what is happening? Why talking so much? Listen to me. You cannot understand yourself. So from petrol pump, you take any sample, it will have some combustion characteristic, knocking property, and there is a opposite to knocking property, call it anti-knocking property. Knocking property less, that is called anti-knocking property. So anti-knocking characteristic of any fuel concern, if it is suppose 80% octane and 20% N-heptane mixture, if your anti-knocking property is matching with that, we call it 80 octane fuel. You have a sample taking from some petrol pump. The anti-knocking characteristic of that, if matching with 80% isooctane and 20% N-heptane, this mixture, then we call, and this is having 80 octane property. So 80 octane fuel. If it is 90% property, then 90 octane fuel. So in the petrol pump it is written more than 85%, 85 octane number. We are supplying more than 85 octane number. What does it mean? Anti-knocking characteristic is very good. They want to certify that their petrol, if you buy, the anti-knocking property is very good. It will be protective for your engine. It will damage your engine lesser. If you use your engine, it will be damaged. So damaging will be less if you are using high octane number fuel. Okay? Once more I am telling. 80% this and 20% this. It has got some anti-knocking characteristic. Your sample, if matching with that, it is 80 octane fuel. If it is 90% and 10% mix are matching with that, then your fuel is 90 octane fuel. So normally, no, more than 80 is desirable always. Less than 80, no petrol pump is selling. Above 80 should be. So that's why I'm taking standard 80, 80, 80. I'm telling 80. Because 80% is supposed to be the minimum level, threshold. And all the fuel, whatever you are using into vehicle, supposed to be more than 80. Octane number should be more than 80. Cetane number similarly for diesel. This is for diesel. Combustion characteristic of the diesel. Here there is no knocking problem. So combustion characteristic. It does not catch fire so easily. So it has to catch fire. Okay, so this particular one, straight chain, this straight chain, cetane. Cetane is actually in hexadecane. Hexadecane, 16 carbon. That is called cetane. So cetane is having this rating 100 and 2-methyl naphthalene rating is 0. Why? Because this branched, long chain or maybe this type of cyclic structure, aromatic structure, the combustion characteristic is poor. That's why taking as concept 0. This I am taking as 0 because the combustion characteristic is poor. That's why taking 0. And combustion characteristic of this is 100 because it's good. Simply good and bad. Okay. Don't make it complicated. Okay, this is good, this is bad. So mixture is medium. Simple. So similarly, this also good, bad. So something in between. Extreme good and extreme bad. Something in between. What fuel you get will be in between that. Okay. Maximum. The worst one and the best one. You don't get the best one. You are not using the worst one. So what you get? In between. Suppose then what should be the desirable Cetane number? 45, 50. Not like octane. No. Octane is more than 80. Here it is 40 is good. 40 is very good. Cetane number 40 means very good. Okay. And for 45, 50 means you are using that for your diesel sports vehicle. Sports vehicle. Otherwise not required. 40 is good enough for any of your trucks. For truck is good enough. 40 above 40 not required for trucks because it is very costly. If it is go for 45, 50, it will be very, very costly. So not required for ordinary vehicle. It is required only for sports vehicles. So Cetane number, octane number. Last of all, gaseous fuels. LPG. You know the use. Okay. Cooking. Everywhere it is used for cooking. Advantages. Highly knock resistant. High calorific value. Disadvantage due to faint odor. Sometimes leakage cannot be detected. Due to faint odor, sometimes. LPG, yes, is used for car. I have seen that in the Jharkhand area, so many people are using this LPG from their kitchen, the kitchen gas cylinder, into their tank and running the car. Some attachment required, they are making it in the local market. Okay. Just like CNG kit, there is LPG kit available. কিন্তু এখানে ধরলে পুলিশ ধরবে অ্যালাউড না এলপিজি কম চলে এদিকে খুব দেখিনি আমি বেশি দেখেছি ঝাড়খণ্ডে চলে বিনা ভর্তুকি নট সাবসিডাইজড কমার্শিয়াল 19 কেজি সিলিন্ডার আচ্ছা সিএনজি compressed natural gas. This is also, it is natural gas. So this natural gas can be of two types. I told you already. One is dry natural gas and this is wet natural gas. Dry natural gas available under the soil, just into the mine, and wet natural gas above the petroleum oil well. So it is comparatively green, supposed to be. This CNG is called green fuel, right? Why? Because less pollution. No, still it is polluting. If you burn, carbon dioxide will be generated, so pollution. But less polluting, that's all. Because other things are less. SOx, NOx, all these problems will be less. Okay, but carbon dioxide will be there. That you cannot avoid. CNG, compressed natural gas, used into bus, SBSTC bus, auto, maybe our vehicle also. Okay, common vehicle, household, normal, our personal vehicle, public transport also. Okay, this is exothermic. Any fuel combustion is always exothermic reaction, and this is the amount of kilocalorie generated. Carbon plus oxygen, CO2, 97 kilocalorie. Ignition temperature is a very important property or characteristic. That's all. I stop it here.